So let's talk about sediment erosion. Okay? We talk about sediment particles that sit on the seafloor, and you need a certain frictional force, a certain critical shear stress to overcome gravitational, compactive, or cohesive forces. So you need a certain shear stress. This can be often expressed by a critical erosion velocity of water. Okay, and you can refer to a certain level above the seafloor, say 1 meter above the seafloor. Once you have a certain threshold velocity, the sediment can be eroded, steered up from the seafloor, and become suspended and can be moved around, essentially. Okay? So once eroded or injected, from a river discharge, sediment particles become subject to transportation by water current. So if you erode a sediment particle here, location A, it can be moved to location B and becomes deposited on the seafloor. Within the water column, suspended sediment particles are subject to gravitational settling, turbulent diffusion, turbulence, and advection. Advection is the movement. So deposition of sediment occurs once the ambient water flow falls below a certain threshold velocity again. So if the current settles down, if the current becomes weaker, the sediment particles settle down and end up on the seafloor. Okay, the erosion event can also release nutrients from the benthic, from the seafloor. Okay, the erosion event itself can release the nutrients from the seafloor. Okay, it's also an important component in the nutrient budgets. Okay, so now let's talk about the most important diagram that you have in the discussion of sediment dynamics. It's called the Hjulström diagram, and it follows on the next slide.